is a qualified GATE scorer in 19 with 91 percentile. Is also qualified UGC National Eligibility Test and ICAR National Eligibility Test for the award of Assistant Professorship. I already told that these are all the areas of interest. He is going to give us some basics of the. I think this is your first session regarding the internet of things. The morning you are having the session on machine learning. I hope you understand some of the basics of machine learning. So as I told earlier, the application is up to you. Okay. Okay. This is the topic. Preeth is going to be delivered. So let us hand over the session to deliver. Welcome.
Good afternoon to all. Good afternoon. Good afternoon. Okay, so as a teacher, we all know how much difficult to handle a class after a good lunch, right? So I want to make it as much as easy as possible. So I won't make you guys to sleep. So it will be much more interactive because this session is like the topic which we are going to discuss. So just feel free to stop then and there. Just stop me there. So we will have a tough discussion so that we can go depth as well as breadth, right? So as Professor has introduced, I am Dr. Preeth. I am heading Hybrid Intelligence Lab as well as I am working as Assistant Professor in Indian Institute of Information Technology Design and Manufacturing, Kancheepuram. It's in Chennai. So I am associated with the institute for the last 2.5 years. So basically in my research lab, basically my area of expertise is all in machine learning in IoT. And we basically concentrate or emphasize on the communication aspects in IoT. So how a hardware aspect can be much more optimized for a communication aspect. So I want to cover both in terms of an hardware perspective, specifically in a physical layer, as well as in the application layer, right? So basically before starting, I want to know how many of you are from computer science domain? Just a rough plastic. Okay, so electronics? Okay, okay, fine, thank you. So how many are from instrumentation? So, great, fine. So it's like a mix-up of all. So we need to go like a plug and play model, right? Something in hardware, something in application, right? Right, no problem, we'll start. So everyone speaks about IoT, right? So this becomes as a very much buzzing word. What is meant by this IoT? But if you believe that I say IoT is nothing but a wireless sensor network, how many of you will accept me? Because this is not a very new topic which has been embraced, this became buzzing in the recent days. Earlier, we are speaking about the same methodology in terms of a network where we are trying to set up a wireless network and logically we try to customize our entire network layer stack or the protocol stack or as my 7-layer stack as how much customizable as possible so that I need to make the entire processing as much as easy. So logically what is the output is, instead of having a mesh network or a traditional ring topology network or a bus architecture network which is in wired manner, now I need to set up a wireless network, specifically while I need to establish the communication between these nodes in a wireless manner. So whenever I am saying wireless, then there are some other parameters that are going to be associated with it, right? So what we have started is like, in initial while I am saying this as WSN, I am saying like these are distributed and lightweight wireless nodes, but these lightweight wireless nodes can be customized or can be witnessed in more than 2 to 3 parameters. That means, I can say this as a sensor, or I can say this as a smart computing device, or I can also say that this is something like a gateway. See how I am trying to bundle everything. One is sensor, which is purely a hardware. Another one is like I am trying to say it's a computing device, which is nothing but an amalgamation of both hardware and software, where it comes as a single entity. Or in other terms, in instrumentation side, we can say like this is like a microprocessor or a microcontroller, where we are trying to do something like that in electronics, right? Or in other terms, that the third in which I am trying to say is, other than like a sensor and a computing device, I am trying to say like a gateway. So what is meant by a gateway? which is like an intermediate node system or hub which tries to facilitate the operation between several networks. So now what we are trying to do in IoT is like, the overall attitude or the overall multitude is going to be stays common. I need to collect the data. At the end of the day, I need to collect the data. How I am going to collect the data? It varies. If I want to put a temperature sensor to note about what is the temperature available in this particular room, then it is all about a sensor-based system which is being accumulating. No, I am not supposed to use this sensor. Let me use my mobile. So my mobile automatically has a thermostat within it. So automatically it tries to give us data. So I put an application layer so that automatically push this data to a cloud. Again I am collecting the data. So this is another way of collecting the data. At the third way, I can say like, okay, let me sit idle. Somebody else who is in the lab, who is going to send the data, I need to surf on internet, or I need to rely on some map system. He will be sitting and saying like, I am in this particular GPS location. At this GPS location, this is my location. I am feeling cool. I am just putting it fit. So again data came to me at Chidambaram, this is the location and this is the temperature that is being there. So what happens now? I am collecting data, variable is going to vary, that means the mode by which I am trying to collect the data is going to vary, but at the end of the day I am getting everything in my packet, knowingly or unknowingly. This is what is an extension of wireless sensor networks, right? So earlier what we will be doing is, we will be trying to have every node as either an originator or a router. That means I will be deploying a node, I will be give a suitable power source, the power source will collect the data will be forwarded to the gateway, from gateway to my overall server, from the server I am supposed to set the data. But now the thing gets changed. I am not relying only on a sensor node. I am not going to rely only on a third party centralized system. I am going to follow a decentralized approach where at the end of the day I am getting the data, but by what means I am getting the data which is heterogeneous, which is not homogeneous. Right? So now we can say like this is self-configuring, this is infrastructureless, and this is a scalable network. So scalable I am trying to say in terms of the number of nodes that are to be deployed. I can increase the number of nodes, I can decrease the number of nodes based upon the requirement, right? So let us say I am trying to get the same temperature data. If X gives or Y gives, it's going to be the same data because it's not about human brain. It's going to be a hardware which is going to give the data and I am going to rely on that particular hardware. That's it. So what is now we are trying to move forward, or specifically what your, this particular workshop is all about is like how to introduce this IoT and machine learning in agricultural domain aspects, specifically. So now I am going to touch the crux of what we are trying to do. So before going to this, I want to introduce about some of the basic terminologies and components that are being there. And the beauty is I want to introduce another one paradigm here. That means inherently or unknowingly, already we are being connected with an IoT system and we are all part of an IoT network which is being developed or which is being connected using internet. The only thing is the person who is sitting inside a room, who locked inside a room, who doesn't have a mobile, who doesn't have an access to outside world, other than him, each and every individual has been connected to an IoT network already. So now what we are trying to do is, we are trying to take some smartness out of it. அதாவது என்ன ஆல்ரெடி ஒரு நெட்வொர்க் இருக்கு, அந்த நெட்வொர்க்கை நமக்கு சாதகமா எப்படி யூஸ் பண்ண போறோம்ன்றத now we are going to see. Right? So logically now if I want to say one thing, like what is the basic thing we are trying to look it over here, this is all about connecting of sensors. So as I said, this sensors may be anywhere. This may be a thermal air conditioner, or this may be something like my smartwatch, or which may be my mobile, anything which has some node, which has some computing facility, or which has a sensor within it. If this is there, then I can say that as a node. So I will be changing the words node, computing device, or IoT hub, everything corresponds to a single wireless sensor node. So again I said why it's wireless, because I am not going to have a wired connection, right? So what we are trying to do over here, I am trying to embed everything with electronic softwares and sensors to the internet, enabling them to collect and exchange data. So what is my ultimate idea is now is like I need to do a reliable data transfer. So when I claim what is meant by reliable data transfer, so am I doubting my existing system of data transfer? Am I saying like this existing system of data transfer is not right or not reliable? So why we are trying for a reliable data transfer, or what we are trying to do? என்ன பண்றோம், எதுக்காக இந்த மாதிரி ஒரு reliable data transfer இருக்கணும்னு நினைக்கிறோம்? Any ideas? Or what are the present challenges or problems in the existing data transfer mechanism? See, as I said, this is a post-lunch session, so every 5 minutes once I want to have an interaction. Else it would be very much boring. Yes, come. Sorry? Right? Data loss. Okay. So to polish the words whichever ma'am is trying to say, I want to say like the data transfer or the data whichever I am trying to receive is not fully being received in my ear. That means if X is being said, some X delta is being received here, some delta amount loss is there. That's what ma'am is saying, data loss. Yes, right. Yes, sir. Okay. So what is meant by storage? What is the problem over there?
We don't have that much of storage in what we are already receiving.
Okay, right. So let me think like I am having a system which is having a stacks of computer or a stacks of processor and memory unit within this particular room. Right? So think like I am having some 100 TBs of process system which are here. Still if I say like there is a problem with my data storage, no one is going to accept, or no one is going to say like there is a problem with storage. Right? So somewhere some efficiency in storage is required, but that is being there. But my main motivation is what are the problems that are present in the communication aspects of data transfer.
Latency.
Right? Excellent. Latency is the main aspect. That means there should be some delay. Right? So let us say I want to sit and watch a YouTube video. If I am sitting here, I am just watching without any buffering, I am just watching my video. If I am going in a train or if I am traveling in bus, then automatically every 10 seconds there is a buffer that is rotating. That means what? The packet whichever I am trying to get, it's not getting there. So there is a latency there. There is a delay over there. Right? That's why we need some training to do. Good? Yes, latency. Anything else? That's what was the first answer I was expecting. Nobody was talking. Security. So now everyone faces this cyber threat mechanism, whatever we are trying to see here. Right? No one is reliable to any particular medium. I am trying to say if any data transfer happens, some K to M intruders are there into that system. That means what? They are trying to fetch out the data. Even I can say the Google also listens what we are trying to speak, even though if we switch off the mic. That's how the recommendation system works. So I will be thinking like I need to buy a new headphone so that this existing headphones are not working well. Next time you go to the Amazon or Flipkart, automatically your first suggestion would be these are all the headphones that are coming with less price or with this thing. How it has. So by any way or some way, someone tries to sit as an intruder and tries to collect the data. So now connect it with IoT. We are leveraging forward saying like we came to a digital India where every data is being connected, every human is being connected to another human in a wireless manner. I can send the data, I can send a song to my friend immediately. If he is connected with Wi-Fi, I am also connected with Wi-Fi. I can say like if they both can send a message not by using a telecom sector, they may use WhatsApp, which just requires an internet that doesn't require a specific telecom. What WhatsApp is being trying to do or Telegram is being trying to do, they all are trying to establish a network not using network providers. They doesn't require any service providers. They just require a common wireless medium. So they are using internet as the medium. Correct? So what happens now day by day is we are trying to make our communications on the aspects as very much crisp or very much smarter, but we are lagging on the big aspect of latency and security. That's how IoT tries to make everything into a single umbrella. How to pitch on these issues and how to make it as a more reliable system. So now I think you guys may get an idea of what I am trying to say is reliable. So now this reliable is a word which has a sub keyword which is also which safety feature, a latency-less or a good bandwidth and a latency, error-free transmission, something like that. So logically, if you see in the backend, so there are two types of connections that sits. One is TCP, transmission control protocol. Another one is UDP, user data graph protocol. Where TCP is what our normal network is all about. I will be having a system, I will be having a LAN wire, and it connects to the another one. There is no problem of no intruder system. That's what in the earlier days it was happening, right? If I want to credit some 10,000 rupees from my account to my father account, I will go to the bank, I will fill the slab, I will put the slip. So the particular cashier will say like, from this account, this much X amount to be credited to this account number. He will raise an indent. So that indent will be communicated via the LAN connection which is connected over here via a dedicated line to some other branch or bank whichever is being there. So it takes 2 days to send the data with an official acknowledgement based system. So today if I deposit 10,000, after 3 days my father will say I got credited with 10,000. But is this happening today? No. I'm just using my GSpay, scan 10,000 and another fraction of seconds somebody there is going to collect knowingly and somebody is there going to collect the data unknowingly that you are having this much money, right? So what happens is, right, we are trying to make our things smarter, but we are not making our technological stack advanced. We are trying to make our entire process to be easier, but we are not thinking about how to make the entire system to be reliable. This is where this bankruptcy or this is where this cyber security aspects are coming into picture, right? So what we are trying to do is like in IoT, right? So it's very pretty, what to say? It's very pretty hard to say. But sometimes we need to understand and accept more than human, I need to rely on. What does that mean? A machine-to-machine communication. That means what I am trying to say. I will speak to a machine, that machine will speak to some other machine, the X or Y who is there at the other end will listen to this another machine. This is what is the leverage, what this technocrats or researchers across the globe are working. So IoT is a subset of machine-to-machine communication. So it's not like machine-to-machine communication doesn't happen earlier. Yes, machine-to-machine communication was happening. Let us say if I want to establish a connection with satellite to the remote hub in India, ISRO does it for last 20 to 25 years. They are able to put all the satellites exactly in the orbit. They are able to connect through machine-to-machine. But now what we are trying to do is, we are trying to make such a system in making this machine-to-machine communication, with some certain features. Now you say, why we are not doing this machine-to-machine communication or IoT earlier? What stopped us from doing it? Or what are all the challenges that would be there if I am going to this kind of network of machine-to-machine? Now we understood why we are going to machine-to-machine. What are all the challenges? Earlier ISRO did, but why it has been not used for a GPay or it has been not used for any smart connections? Why we are still relying on a manual connection or like, let us say, post office? It would be very much shocking to say, think about the functioning and the system of a post office down the line after 15 years, how it would be. There is no wonder if it becomes like a museum to just go and see how stamps has been done. Because everything has been happening over e-transactions, emails and e-signatures, right? So still we need a system like that which is a common mode of communication. But think about the efficiency of a specific system, something like that. I'm not saying post office is not required, but I'm saying how we are trying to advance our technology in all the domains. We are trying to make all the systems over there, right? So what is the advantage while I am going to machine-to-machine communication, and what are all the problems I would face if it is a machine-to-machine communication, and why it is being not done earlier? That is my question. Why? Why it is not being done in earlier? Any random thoughts? No problem. Just you can try.
Internet is unknown.
Good. We doesn't have a stable connection. We doesn't rely on a good infrastructure where I can communicate properly. Right? Let us say if I am saying one district, probably the number of cell phones would be, the number of cell phones will be in 2 digits, and number of telephones may be in 3 digits, I don't know logically, because while I'm studying in school, I still will be standing in the queue near the PCO to speak to our friend, right? So this was the thing which was happening. Good, there was no proper communication, so nobody thought about machine to machine. Now there is a good communication setup, so they are thinking about anything else. Wait, what is the need? The next major challenge is what amount I should invest to deploy this particular one, right? If I want to say like, I want to send a money of 10,000 from my account to my father's account. If I want to take a bus from here to something like I said to Chennai, I need to spend some 150 rupees and I need to say, give a money to him, okay? If I am saying do it using machine to machine, but you need 15,000 to establish a connection and you need 10,000 to transfer, will anyone do that? Who is going to care of, for sending 10,000 I need to spend another 15,000 bucks for sending a data of 10,000? Nobody is going to care. So earlier the thing is, we thought whichever is a costly affair of communication medium has become a cheaper affair today. That's what this intruders, this cyber security, everything came into picture saying like, okay, we are also in a cheaper fashion, we want to play with this market. So now this machine-to-machine communication is becoming increasing at a rapid rate, but at the same time, the amount that is being required to establish such a setup is very minimal. You won't believe, in our lab, I will be showing this test case study. We have tried to mimic a small fire prediction system within our lab, and the entire thing which is being required is 12,800 rupees. Think about a fire protection system which is being fitted with fire extinguishers which are being there in an entire system or a big establishment, right? So that's what all about my research project is all about, right? So think about how smarter the way is going on. So now, what is the takeaway? I cannot just throw away this technology saying like this is not safer or this is not reliable. Right? பிரச்சனை இருக்கு, advantage இருக்கு. கரெக்ட்டா? So நம்ம இப்ப என்ன பண்ண போறோம்? As an engineer or as a researcher, as a technocrat, we know these are all the problems, these are all the things we are trying to do. So now we have came to one system where I can say anything, anywhere, at any time. Right? That means what? Whichever comes to my mind or the thought process, I need to communicate it with them. It can be done at any time. That's how we generally discuss in office also, right? Previously, when something is being given to our colleagues or friends, we will require some meeting. So in the meeting they will say and we will discuss. But now is it happening like that? Everybody has a WhatsApp group. So any information that is to be communicated, even it is night 12 or 1 or 2 p.m. or 4 p.m., just put it in the WhatsApp. Everybody should know and everybody should adhere to it. Right? That's what I am trying to say, anything, anywhere, anytime. Sufficiently, everybody is being connected with internet knowingly or unknowingly. So this internet connects all the people. So I can say this is internet of people. When everything is connected with people, why I should not say this is internet of people? Is it only things are being connected? Is it being only two mobile phones are connected? One hardware device and one another software, and microprocessor are being connected? No, everything is being connected. I can call this as internet of people. So why this word internet of things comes into picture is like, now everything is being connected, everything is being common over an internet. The only thing is it may be a thing, it may be a human, it may be a vehicle, it may be an agriculture, anything. Right? So that's why if you see in internet, you will be seeing IOV, Internet of Vehicles. Next there is a technology coming, IoT, Internet of Drones. Who is going to scold us? Why drones cannot connect, why persons can connect? That is what is the advancement in technology. We are trying to identify the merits then and there, and we are trying to accumulate those merits, and we are trying to take it further. Right? So now, coming back to the system. Can I say, see this diagram, right? So during class we'll be saying it in a funny note, that's why I have put it here. See here, there are totally 3 dimensions, so we are good in math, right? So we say like always a person's dimension within single dimensional person. That means what? If I want to be angry, I will be angry. If I want to be laugh, I will be laughing. If I want to cry, I will be crying. If I want to make fun with me, I will be in a fun mode. But now, because of this thing, I am having a 3 dimensions for a single human. That means what? I won't be happy with a certain system. But I will say, yes, fine, this is really good. Correct? So who forces me to? Even though if I am not happy with this domain, I am just communicating with a human. So what it does? Human doesn't have any human neurons with it. If something I am trying to say in a sad mood, saying like I am happy, system understands like he is happy. He is not a person to understand like, no, his face is not looking good, just he is typing I am happy. Right? So that is the difference between human to human and human to machine. While in the 3rd dimension it comes, human to think, it becomes very simple. So what we are trying to do? We are trying to convince anyone, even though if you are not in a good state, or in other terms I can say, we are trying to make some interpretations wrong, even though if it is right. So this is a very funny thing which we need to know. Any communication medium at any time, at any place over the number line, or let us say in a spatial information, I am trying to do any particular idea to be communicated at anything. This thing corresponds to a device, or my mental state, or anything. I am just trying to say it's calm. Right? So now, coming to this particular setup, I need to sense and control the physical world. See this word control. Who is there to control the physical world? Let us say previous, 4 days back, there was a good, I should not say the good, there was a strong cyclone Bengal. Right? There was many predictions, it would be there, it would be here. But at last nature won, right? We are unable to do anything for that. There was a major drastic amount of loss in terms of agricultural lands and several other infrastructures, everything, right? So no one can control the physical world, but what we are trying to do is, we are trying to monitor them as a parameter. That's what in IoT we are trying. How I am trying to monitor? I am trying to say last 10 days the temperature is like this. So logically, if I am putting an exponential moving average or with a mathematical modeling, I can predict at the 11th day this temperature would be here. So I am just trying to predict, but I cannot control. But what here we are trying to do is, I am trying to say, I am trying to make some smarter connection using this intelligent network. So now this intelligent is coming into a picture instead of controlling. So what I am trying to do? No, you cannot control the physical world, but you can intelligently handle the situations that are there in the physical world. So how I am supposed to handle it intelligently? So that's what government is trying to do, right? They are trying to set up some control centers. They are monitoring the parameters from the sea. They are getting the information from the NDRF. They are trying to say these are all the districts that would be majorly affected, and these are all the things we need to make it a precaution. So now the system is same. The event that is going to occur, which is going to be cycling, that is same. But the steps are the precautionary measures, are the step to the items, how we are trying to communicate to the people that this particular thing comes or this particular cyclone comes, that waves. Right? So that is what is known about intelligent network. Right? So now I am trying to go directly to how I am trying to make a system which would be more intelligent. Right? So coming back to this particular system. So I hope everyone have a clear idea about what is meant by IoT. So it's nothing but an end device. And the next clarification is, I need to set up a good communication system. As ma'am said, it should be secure and reliable. We saw which is secure and reliable. And the next thing is, we saw how intelligent should be. So since the overall communication is very much easier to do, the overall process should be less. So this is very clear now. Now, there are several ways by which I can do it, right? But there are two specific areas where we need to concentrate more. One is the geospatial region, or this geographical signals, and another one is this energy. This is where most of this electronics and instrumentation people will be working. I'm having a device, right? I'm having a device, but how to make a smart powering source for it? I'm having a good reliable system, but it's always connected to power with a high-end, it requires a good amount of input power source, but I need to do it in a lightweight power source or in a minimal power source. These two are the major parameters which this electronics and computer science people, it cannot be done in a single-handed, it should be bundled and it should be done. Right? So that's where the main area of this problem. So what I am saying is geographical signals. Generally, let us say today I am here, yesterday I was there in Chennai, again today night I will be there in Chennai. If somebody wants to track me, if somebody puts a GPS node within me, which is again a sensor node, it's going to say what is my latitude and longitude and position. So logically my mobile phone is having GPS node within it, so it automatically says yesterday you were in Chennai, today you were in Chidambaram, today night you will be in Chennai once I reach there. So what is happening is like using these nodes information, I am going to get this particular location information. But when I am saying I need to establish this particular network, as she rightly suggested, I need to do it in my right standard, whether I am supposed to initiate a communication or not, based upon a location information. Then my intelligent processing can be done conveniently. That means I am trying to say, if I am trying to say, in my home I am having a safe, I am putting all my money and my jewel within this particular safe, while I try to say, this particular safe is safe until thief doesn't know where I have kept it. Right? So where is what is all about location. Right? Where I have kept it. But if I am going to say to my thief like I am going to keep my money and jewels, everything here, so it should be safe. I think it is safe, so it will be safe, and if I leave, surely my thief will be trying to attack. Right? That's where this geographical processing and this location processing comes into this picture. So now, this overall entire system process is divided into three problem statements. The first problem statement is where I am trying to communicate. The second problem statement is how I am going to communicate, at which location, whether the process whichever I am trying to do is right or not. And the third particular thing is by which medium I am trying to. See, how much big problem is being there. I am trying to segregate it into just three sub-aspects. One is, I need to know the location to make a suitable decision. This is where this machine learning and other algorithms comes into picture. Second one is, to whom I should say the information. That's what my infrastructure, how safe my infrastructure is. Third one is, whom I am going to rely to send this data, which communication. And one important thing, if I am claiming that there is an IoT, is there always we need an internet to do its scope? I thought of having this at the beginning, I forgot. Do we need internet to exploit or to implement a network of IoT? This is my question. Yes or no?
Yes.
Okay, you say how many yes? Majority? Okay, no. Okay, and I'm always a person who thinks about why it can be not be known. So can any idea about why it can be known?
Using Bluetooth or like infrared, I can communicate with this AC. That is also, it's not like an internet.
Excellent, good, very good answer. Right, right. Okay, actually the answer is no. Whatever he said is very much right. So whenever this internet is nothing but just a medium, right? If I am trying to do a connection between a particular remote and a TV, which is being done using an infrared connection, still it's a machine-to-machine communication because remote is a device, TV is a device. I am trying to communicate, but now when I am saying it is an IoT, the only aspect is based upon my mind or based upon my process that is running in my mind, automatically this remote should change the channel. This is what is IoT. It's not like always internet should work. That means if I want to see a cricket match, then automatically the system should give me a cricket match. If I want to say like I want to watch a movie, I am supposed to put it with a movie. This is what is all about this intelligent thinking process about an IoT system. It's not about always an internet is being required. And in addition, as he said, we can establish a network using Wi-Fi or Bluetooth, or there are several other industrial protocols which are known to be as LoRa, which is what now government is trying to implement everywhere. This, what is this? I don't know, this medical, IIITDM, right? Something, they are trying to connect all the rural hubs. How they are trying to do? They don't want to deploy a big infrastructure of hospital over in rural setup. Instead, they want to send some specialized people over there, collect the data. This data alone will be transferred from one place to another place. That is what is this long range networks. That means the bandwidth or the amount of data that can be sent will be minimal, but the connection established and range by which it can communicate, it is long. That's why it is this long range network, right? So now it's very clear, it's not like always infinite is being required. So as I said, now location is important. Now we will see. Go to a very basic thing. I doesn't know my location, but still I need to know, or I still need that particular information. How I can find? I am not having a GPS, no? That is what is all about IoT device, right? So what does that mean? If I am having a remote, whether I am having a remote, I am trying to operate my TV over there, I need to try to establish a communication. As a human, I know where is my remote, where is the TV. But whenever I am saying a smart network, automatically the TV should be known where it is being installed. This remote should automatically know where it is being present. So now trying to think, or now we are trying to put forward how to make this location intelligence to be possible. That means what? I am not having any GPS node with it. But I need to still know, I need to still identify that my latitudinal and longitudinal information should be known.
Based on prediction.
Sorry?
Based on prediction.
Sensor.
How I will predict?
Like what is your next move?
Okay? But for that I need to say, right, let us say I am here, if I want to go 3 steps, I am saying I am going to go 3 steps. So then I know my location. I am just saying there. I may go randomly here, I may go randomly here. How I will predict?
So if I have a geographical understanding of area,
Good.
I can use my other smart devices to find out my location.
Excellent, excellent.
That's what is being used in maps, where you can use map without.
Great. I think so now I am getting some good amount of audience who is trying to follow me. Geo-referencing, good. Still. Okay, recognition is something different. Okay.
Sensing parameters, sensor. Connecting parameters.
Okay, what? Okay, good. So, okay, I am taking this word sensing parameter. Now again the question is, what are all the parameters that require to do this location identification? So now these parameters, let it be parameters. Good. Georeferencing parameters. Right. Now I am going to one step forward. As he was trying to say, like, I need to know about my geographical mapping, or by making the smarter devices connect them, I need to find that location. But if I want to communicate, or if I want to know a connection where I am being present, if I am saying like, I am just standing 2 tiles near to this gentleman, I need to know where this gentleman resides. Right? If I am just saying I am 3 tiles away from this man, then I need to know where this man resides. Everyone is accepting this, right? But no one is having GPS, right? He is also not having GPS. So he also doesn't know where he is there. She also doesn't know where he is there. Am I right? So in more simpler terms, if I want to say I am standing near the main gate, then for that there should be a main gate there. And I should know where that main gate is residing in this particular campus. If I want to say I am standing near guest house, I need to know where is the guest house location is there. Right? Good. Now you guys came 2 steps forward. Now you think how to make it possible. Sir has rightly put it as geo-referencing. What is this geo-referencing tries to do?
Satellites you can tell what longitude you are.
But satellite, I need a GPS node to communicate with satellite, right? Yes, I cannot communicate with satellite. If GPS is there, then automatically I will communicate. I am not having GPS. Something like landmarks are there, right? So what is the thing is like, now I am trying to make a network Think like this is my overall map in an IoT system. We all are nodes. We all are IoT nodes. Right? Think like that. We all are IoT nodes. This is my entire geographical system. Right? We doesn't have any GPS. But I am trying to say, everyone please locate yourself. Where are you? How you will locate?
Based on the main perspective, sorry, main object.
Okay? Who is the main object?
Like this.
The master is
Okay, something like master. Still find you.
reference.
Yes, now ma'am come to the point. Some references. What will be the references here? This may be one reference,
Yeah.
one main door. That may be one back door and exit. There may be one reference. And I can say this podium is one reference. So logically I can say I doesn't know where I am standing, but I am standing near the podium. I am saying what I am saying is right, correct? I can also say I am standing over there at the last bench, which is just one tail behind to my exit window. Right? This is what this GPS and geo informational systems are being. I am sitting in my car. I am just putting how to reach to Chennai. It will not immediately say go to the bypass. It will say go 30 meters straight, turn left, take the roundabout near the Chidambaram bus stand, go straight. So where it starts, it gives me the references with reference to the landmarks that are being present. It directly doesn't reference with respect to my GPS node. Here GPS is being used only to identify what is the distance between myself to Chidambaram bus stand at present. Then after reaching there, what is the distance from Chidambaram bus stand to the bypass or something like that, it is trying to establish. Right? So now I am trying to bundle everything into a single pack. I need two things. One is reference, another one is communication. If these two things are there, then without GPS, I can locate myself. Yes or no? Correct? Sorry, I got to put my phone in silent. Right. So now, coming back. So something like a reference point. Now I am standing here. So I am thinking like this is my reference point. Right? So I am saying like this is my reference point, and I am logically in an inclination, I am just saying 8 to 10 tiles above from this particular thing. Right? By using the single reference point, can I exactly find my location? So we all studied the basic mathematics, right?
Refer from 2 points.
Okay, why 2?
2 or more points.
Why more?
Enough coordinate.
Accuracy.
No. Now relate. Yes, accuracy comes into picture. Good. Now relate with. I need latitude and longitude. How many unknowns? 2. So to identify 2 unknowns, how many equations are required? Relate with mathematics, right? So if I need 2 equations to solve, right? Then unknown, by using 2 linear equations, I can solve 2 unknowns, right? But I need 2. That means what? I need what is the distance from here to here, some referencing, from here to there, some inclination. Now 2 equations are there. By solving these 2 equations, I know what is x1, y1. I know what is x2, y2. I am xk, yk. By solving this, I can find what is xk, yk. But in real time, in a localization system, it's all about solving 3 equations. This third dimension comes with respect to time degree, right? So generally this third dimension degree is also required to find the exact location of x, y, because I can model this entire system as a 3-dimensional model. If I want to find what is the location of that AC, if a 2D system is there, I cannot do it. I need to know at what x, at what y, what is its depth. Right? That's why in location identification we will be using 3 equations. So now what is the requirement? How can you say to identify a particular person's location? I need how many reference points? 3 reference points. Next one is, if only reference is there, can I find? I mean, I am saying like I am here, that door is somewhat this much distance, somewhat this much distance, somewhat this much distance. Now I am saying somewhat, correct? I need to know what is the exact distance that is being there from this particular location, or I mean from my position to this door, to that door and that door. This is what is known to be in mathematics, we will be calling this as trilateration approach. Right? So this trilateration approach is what we are trying to do, is specifically I am trying to use 3 anchor nodes. So think like anchors are hereafter known to be as references. I need 3 reference nodes, and by the concurrence of this all the 3 reference nodes, I need to identify the D, D1, D2, D3. So in a simulation setup, we will be using an equilibrium distance parameter. You may use geodesic distance also, anything, right? So this distance metric can be used, and I can try to find what is this target node of XZ, Y. This is how spatial and geo-information systems in IoT works. So, see the beauty, I cannot say I doesn't need GPS, but at the same time, I cannot claim all the nodes should have GPS. So to localize the persons, there are nearly some 30 persons there, I need 3 reference points. And logically, these 3 reference points should be within the range of each person. I cannot say someone sitting in that particular room who can see this particular exit door is present or not, but I cannot say find the distance between this door and that door person, because he doesn't know there is a door that exists over there. So that is why I am drawing a sphere over here. This is what is representing the communication range. This is what in mathematics we will be calling that as trilateration, where multiple dimensions goes, we will be calling that as some multilateration. Right? So now I am trying to find this location of XZ, YZ. Again, coming back to IoT from mathematics. Let us say I am having this water bottle. I am just putting my device over there, fitted into this water bottle, and I am just throwing this water bottle. And I am trying to say, after each seconds of T1, T2, T3, T4, T5, identify the location of this particular water bottle. Can we do or not? We can do, because I am saying this particular water bottle is within this reference range of this particular system, right? This is what is known as location intelligence in IoT. So for the next 30 minutes, we are going to see how easily we are going to do this location intelligence. I am using the word easy, but it cannot be not done that much easily. We need to know certain mathematical models and optimization techniques to understand the same. So I will be trying to touch here and there. Right? So these are all the steps that are being done in a location identification system. First one is node deployment. What is meant by node deployment? That means I need to find where I am going to deploy my node. I mean, where, in which environment I am supposed to fix the persons. So I mean, if I am saying like all the 30 participants may sit here and there as per their own choice. The second thing is setting at the node range. What is the node range? That's what. If I am trying to find what are all the reference points, all the reference points should be within the communication range of a particular node. That's what is happening, right? Let us say I want to communicate to my wireless Bluetooth or to my Bluetooth headset. I may keep my phone over there. Up to 30 meters, I can, up to 10 to 15 meters, I can get the signal without any break or without any loss. If I go behind 15 meters, surely there would be a drop. Surely there would be a data drop. If I go past this door, then I will not hear whatever it is being happening. That is what is the communication range of a Bluetooth range. If I am saying Wi-Fi, Wi-Fi can adopt up to 15 to 20 meters based upon the facility of the device and the configuration of the setup, right? So if I am going more than this, that if they are considered like there is a Wi-Fi network, I will be showing if I am standing here, the signal is 100%. Go some 10 steps back, check the network, 80%. If I am moving slowly, so it's directly inversional. While I am trying to move away, automatically the signal strength also will be getting reduced. Right? So the second important parameter is I need to set up the communication range, because it's not always about internet. As I said, it's not always about internet. We need to establish a network either through Wi-Fi or a Bluetooth or a Zigbee or an IR, whatever may be the setup. The third thing is determining the communication medium. That's what I am saying. Now I said what is the communication medium. So these two are bundled into a single setup. That is what we will be saying that as a communication protocol. So this Wi-Fi, Bluetooth, and Zigbee and ESP32 Wi-Fi module, these all are some of the communication protocols. That means it says up to what range I can establish the communication. That means I can identify you if you are just this X meters distant from me. If you go above this X meters, I don't know who are you. Right? So that's what is our second. And the third important one is impending the external factors. What is it? Impending the external factors. Environmental factors. What are the environmental factors that is going to affect? Right? Climate. Anything else? So in technical terms, we will be calling this as noise inference ratio. Right? So whenever I am saying like I am there as a system, if it is full of vacuum, then I can say that data whichever I am trying to say from here is 10% reliable so that everyone can tell. There are several other noises, there are several other noisy parameters within us. If I am speaking something over there and something above next to the wall is trying to hear, then surely there will be a dropout. He cannot get that much visible or that much audible what I am trying to speak here. Right? So these all are known to be as external factors. Now I should also know what are all the external factors that are going to affect this identification of distance metric from this location to that particular location. So that is what is known impending the external factors. After noting all these, we will be creating a cost function or we will be building a model by which I can identify the location of a node which doesn't have a GPS. And logically, one thing should be clear. It should not be always a static node. If I try to find a location of a static node, then there is no need of localization. Right? What is the meaning of a static node and the difference between static and dynamic? If I am trying to find always, if I am saying this, yes, constant, good. If this podium will be always there, then there is no meaning in finding the location for this. Because always it is going to be D1 from this particular reference range, D2 from this particular reference range, D3 from some other reference range. It's not going to change. Right? If I am saying bus stand, always bus stand would be there. Tomorrow bus stand would be somewhere else and day after tomorrow it will not be going somewhere else. So in IoT, our ultimate idea is to find a location of a moving target. That means I am considering all are in motion. Whichever I am trying to find the location. Right? So in general, I will be trying to find the distance estimation. So this is a very basic fundamental formula. K by d power alpha. Alpha is the attenuation exponent factor. Or in other terms, I can say this is nothing but the noise ratio. Right? So what I am trying to say in more simpler terms is, if I am standing somewhere, if I am trying to speak with this gentleman over here, if I am speak here, it would be more audible. If I am standing over there and I am trying to speak, some alpha percentage of voice drop would be there. So based upon the distance, this alpha varies. That's why I am saying K by d power alpha. So in electronics, I think many of you would be knowing, we would be trying to compute this received signal strength parameter. Right? So what is meant by this received signal strength parameter is, what is the signal I am trying to get in terms of distance. If I am saying I am 10 meters away from my router, then I am having a signal strength of 90%. If I am saying I am 80 meters away from this particular router, then my signal percentage is 20%. Right? So what I am trying to do, if I am getting increased distance, then surely my signal strength is going to reduce the distance. Right? So that is what is known to be as received signal strength. So how we can get a strength? Signal strength, any idea? Between these two nodes. How can we find a signal strength between two nodes? Because we are, I think many of you are from electronics, right? Because we guys don't know, but the electronics guys surely knows about because earlier I too don't know. During my PhD I have referred and tried to know. So how we will be trying to find the signal strength? What's required? We need antenna, right? Right? We need a separate hardware which is known as antenna. Right? Without antenna we cannot find a signal strength, because the signal strength is not working in a one-dimensional case. It is all about an angle of inclination. So it may be in several angles I may be receiving the signals at different rate. So I cannot model it into an 1D network, right? So we need some antennas to do it. But again I am trying to say, to find a dog, I need to use an BMW car to do it. I need to purchase a BMW car to find a dog. Something like that. Because you know what is the cost of an antenna, right? So instead of buying an antenna between and putting between these two devices with an antenna transmitter and a receiver, directly I can put a GPS node within itself and I can do the process. Because GPS node is that much not costlier than this, right? So now again I am relying on the same IoT. I am not trying to estimate in terms of strength, but I am relying only in terms of this D distance. But I can find the distance easily without using antenna. That's what we found. What we can do is, one particular node, it may be a normal sensor node fitted with an ESP32 module. I am trying to send randomly some packets of data. Send some high. And a particular receiver, another one particular node will be there. That particular data would be receiving continuously as high. Whenever I am going to make this particular device, the distance between the sender and receiver, the distance is increasing. The time in which this particular high gets received over there, it will be varying. By which I can say, there is no change in the distance between the sender and receiver. That's what we are capitalizing and we are trying to find the D. We are going to shortly see how to find the D instead of signal strength. But in real time, how this geosatellite and GPS nodes are being communicated is using the signal strength. That's why I have put this way. Always it's not about distance, it is from the strength we are trying to estimate the distance. So this is how we are trying to find the relation between D and strength. But in a real-time system or in a low-cost system or in an IoT system, we are not going to use antennas and receiver. We are going to use normal nodes and we are trying to find the distance. So what we are trying to see for the next two modules is, we are going to see how to find a location identification in a closed network or an indoor setup. I have tried to use one optimization function to optimize these nodes. Logically, it's again lateration. After trilateration, we need to specifically use some of the optimization functions to find it. So that's what we are going to see. And another one thing is how to use this machine learning into this, because that is what is the crux of this particular workshop. So how to use machine learning into this. And how we have set up a real-time, a case study discussion we are going to see quickly, how we are going to see this modulus concern, right? So logically, Professor, what is the time I am expected to complete? Still how much?
You're taking another hour.
Okay, fine. Great. Is there any break in between? No, right?
No, at the end you.
Great. So then I can plan accordingly, right? Okay. Now, think like, okay, I'm just going random, yes. Think like this is my network. Think like I am deploying a robot. And this robot moves like this. Right? That means, what is like is just follows a curve. Another one is it just follows like a sigmoid. Right? Something like a sigmoid. Right? So, if I know this particular location of which I am trying to show, there is a point that is being highlighted, right? If I know this particular location, so logically if you want to see, it is nothing but 3, 7, because this is a 10, 10 graph, right? The coordinate position is 10, 10. So if it is 3, 7, can I identify what is the location it would be there at this particular point? Can I identify the location of what will be the location at this particular point and at a certain time interval? Yes, right? Yes, because I know the curve equation. So to find, we need to know the velocity of this particular particle that is being moving, because if it is differing velocity, I cannot do. Right? If I know the path and as well as if I know the velocity, then directly I can try to find what is the distance. So that was Kepler's law says, right? That's what Kepler's law says. So while we know about the dimensionality of a particular system, if you know at what particular system a particular atom is being rotating around in velocity and at a particular time instant, I can easily capture it. But is it how real-time data points would be? So what are real-time data points here? We are real-time data points, right? So do we follow specific velocity and time interval and curve equation? No, because I will be walking sometime like this. Let us say if my tea or my food whichever is very much known to me, or if I am very much fond of it, I will run and I will go and grab my food. Right? So velocity varies. And can I always say you should always walk like this only? I don't know the path. I will be walking like this. I will go like this, something like this. Right? So these curve equations for simulation setup is fine. But for a real-time setup, we cannot model the curve equation as well as we cannot find what velocity a particular moving object is. So both are unknown. If we know this moving velocity as well as the thing, then even without knowing this trilateration of this reference points, if I know what is my initial location, then I can find. I don't need 3 reference points, but I need to know at what location I am starting. That means what? I am starting from Chidambaram bus stand at 10 a.m. in the morning, and I know my vehicle is going to come only at 10 kilometers per hour, and I know at what path I am going to follow. Then I can exactly say by 10 a.m. 3 a.m. I mean at 10 3 a.m. where I am exactly looking at. Because I know my velocity, I am trying to predict, I know my path. So at 10 3 where I am going to be there, I will be knowing exactly. But here both are unknown. Velocity is not known as well as path is unknown. So I have taken this example to specifically say how complex problem we are trying to model using an optimization system. That's what I am trying to project over here. Right? So logically this I have tried to put it in an emulator to just say if I know my path, if it's a Gaussian curve, or if I know my curve equation, and I am trying to say at this velocity, then automatically an existing system itself predicts what is the location where it is moving. It will be saying 2,6, then slowly it will go here, it will say 2,3, 8, then here it will say something like 5, 9.2, while it goes here it will say 10, 10. Right? So but the real-time setup is not like this. So what is been happening over here is like, the real-time setup would be looking like this. A model is being doing, a model is trying to deploy. This is what we have set up in our lab. What we are trying to do is, we will be making some persons to move here and there. And these are some of the reference nodes that are being placed as a reference point. And now, the distance between the point or a person who tries to come in with respect to these nodes, it tries to establish the distance. By the distance, it tries to establish its location. Right? Because one will walk at a different pace, another one will walk at a different pace, the third person will be walking at a different pace. Right? So what we have done this is, we have taken this as an experiment for a fire prediction system. So what we are trying to do is like, we are creating a sensor node which is a thermostat sensor, and it is being coupled with an ESP32 module. I will show you this particular, this is the device. So we are having this sensor, and we are having this setup with this model, right? This is an ESP32 model. So what it tries to do is, it collects the temperature sensor node, and it tries to find at what distance I am with respect to this main node, at what distance I am with respect to this node, at what distance I am with respect to this node, and it tries to send it to the server. Now server computes the same, like you are at this x comma y, and it should be again sent back to the person itself. That means what? If the temperature for the last t instances are going to be 35 degrees Celsius, suddenly at the tk instance, if the temperature is something around 60 degree or 80 degree, then surely I should be alerted. Okay, something there is wrong over here. At the previous instance, the temperature is this, now it go above a threshold, so there may be a fire, there may be an untoward incident, or there may be some abnormality, so I need to find the location of the same. Because it's not like always I need to find the location. Because I know I'm going to start from here and I'm going to go to the gate. Who is going to care at the in between kth second, where are you going to be? No one is going to care. My only thing is, whenever I am not been reaching there after this k instances, then I should say, okay, some problem is there. He should have reached here at this point, but he have not reached this point. So now we are trying to model the same problem of location identification as an optimization problem. So what is optimization? I am starting at 10, then logically at 10 1 am I should reach the exit door. If I have not reached the exit door at 10 noon am, then some abnormality is there in this particular environment. Point number 1. The second cost function or the second criteria is, I am trying to sense around me. While I am trying to sense around me, I am having a constant temperature prevailing around it. While I go at a specific location, immediately the temperature gets a substantial increase, then immediately there is an abnormality at this point, so find the location where I am. So how many of you have heard about a major disaster fire accident that happened in Korangani in the year 2013 or 2015? Have you heard? Many of them been right? Near Teni. Right? What happened? The firefighters were unable to identify where the fire outbreak has happened. They were seeing the fire. They are trying to trace out the persons, those who have got as casualties within the fire, but they doesn't know where does its origin or where does it come from. So that's what is the overall crux of thinking. I need to address such kind of a problem, and that's where it all started. Okay, again that's a different story, I should not go behind it. So I am trying to say what is the source behind it, right? Right? So what happened is like, I need to identify the location. So this location identification should happen immediately. That means if a fire happened at this time, I need to find the location instance and it should give it back to them immediately with a limited latency, as she said. I should not say, you give me the D1, D2, D3. I will give you a location after some 10 days. Who is going to care about it? Right? So how efficiently a data transfer can be done to accomplish this task. Right? So now 3 problems we are going to address. First problem is the velocity and the path is not known. Second one is I need to understand a particular position where I need location. Always I doesn't need location because I am not having GPS node and I am running with a battery power source. So always I cannot do a distance estimation of D1, D2, D3, D1, D2, D3. So I need to find the D1, D2, D3 only when there is a requirement of a threshold above of temperature is there, a threshold above of certain event is there. This is point number 2, and point number 3 is I don't know how to model this as an optimization experiment or an optimization function, because this is all about approximation. We cannot directly specifically say at this point you will be there. I can say at plus or minus this would be the dia where you are specifically located. Right. Right. Now coming back to the system. So this is the overall architecture now. So is it clear up to now? I want to just give a pass over here. Any doubts? I want to clear it now, because now we are going to come into pure optimization function and model building. Is it clear? Right? So what is the problem statement? I need to, what I am trying to solve now? I need to identify the location, point number 1. of a moving node. That is very important. I need to identify a location of a moving node. Given the condition that the velocity and path is not known. So these are my unknown parameters. Velocity is not known. Because we need to model it as an optimization problem, right? So we need to know what is known, what are unknown. The known parameters are, I can get D1, D2, D3. I can get D1 and D2 and D3 sufficiently if I am within the communication range. If I am not within the communication range, can I find the location? No. Right? That means what? If I am saying 3 reference points are here, I can find the location of all the persons those are sitting here, not the person those are sitting in the next room. Right? So that's why I am putting 3 spheres over here and 3 circular regions over there. So now coming to the pure computer science aspect is like, we need to transfer this data, we need to find this location and send back to the user as much as early as possible. That means what? I need to use an efficient routing algorithm to do this. So logically in computer science we will be using 2 shortest path finding algorithms. What are they? Okay, K nearest neighbor is again an supervisory learning based approach. Don't go for that. Normally, no, not nearest neighbor. I need to find from here to go to that place what is the shortest path. Sorry? Clustering. Okay. So what are the shortest path finding algorithms in CSE? Whatever you guys are saying are all about NP complete problems and graph problems. Normally I am trying to model this particular room as a graph. Graph means what? Node. Some edges. Right? So now I need to find a distance between a node A to node D. Okay, let me show this graph. Then you can think like this. I need to find what is the shortest between A to C. I can go via A to B to C. I can go via A to S to C. I can go via A to B to C. 3 paths are possible, right? No? Digistas algorithm. Good. So that is the shortest path finding algorithm. It should be used in traditional approaches to find the shortest path between my source and destination. There is another algorithm that is known as Floyd-Warshall algorithm. So that's all about finding a shortest path, but that is all about all-pair shortest path. So what is meant by all-pair shortest path? I am trying to find in Digistas a single source shortest path. From A to C I am trying to find it. But if I am using a Floyd-Warshall, then it will give an algorithm which suggests what is the shortest between A to D, what is the shortest between D to B, what is the shortest between D to C. For all the existing vertices, it will give what is the shortest path. And those who are not from non-CSE background, I am trying to make it very simple. It's all about pure mathematics. What it tries to say is what is the D between A and D, what is the D between A and B, and it tries to find. Logically, if I am saying the edge weight is A to D is 5, D to C is 6, so the cost cubed for A to C is 11, 5 plus 6, 11. If the cost between A to B is 3 and B to C is 5, then the cost required is 8. So logically, it will take A to B and B to C. So what we are doing as our normal human brain. If I want to go from here to bus stand, which is the shortest path if I am going by a small road, so that is the shortest path, surely I am going to take it. Something like that. That's all. So now coming back. Now I need to find the shortest path in communicating this problem, in communicating this location. Because I found at this location, the temperature is very high, so surely I need to intimate to my server that there is an abnormality here. I should not take a longest path, I should take a shortest path so that this data should be sent over there. So this is the third criteria. So first criteria we know location of an unknown node. Second is we doesn't know the parameters, the known parameters are only D1, D2, D3, and third parameters are what is the shortest path or how shortly I can transfer the data from here to there. Third. Right. Coming back. So see this particular architecture diagram. So here I I am trying to find this target node of x comma y of this particular node, right, of this particular node, and I am trying to find the d values. So what I am trying to do, arrange the RSS values in ascending order. What I am trying to say over here? Any idea? Let us say if I am going to have more than 3 reference points within the same room, then what I should do? I am saying like I need to find the distance of myself. I doesn't know the location of myself. I need D1 and D2 to D3, but I am having nearly 5 reference points within this room. But I need only 3. What I will do? Which is the nearest, or I will say which are all the nearest D values or more reliable D values. Let us say I am going to say the distance between myself and this room is going to be, let us say, some 3 meters. The distance from here to there is 10 meters. From distance to here is for 5 means I will arrange all the D values and I require only the top 3 values which are of nearest D values. That is what I am putting in the algorithm. Arrange RSS values in the ascending order and I am trying to take which are all the nearest, because I need only 3 D values to compute the XY. We already saw why it is 3. Right? I don't need to go back. Again, same trial equation. Now, I will come to this fuzzy inference engine later. Now, after this, I need to find this distance estimation. So, what is this distance? Already I found the RSS. But what is this distance estimation is all about? We have thought about another important problem that is prevailing in the network. That is what is known as noise inference. So whatever may be the D1, D2, D3, whichever I am getting, these are not true Ds. I need to optimize this Ds. That means what? I need to say whether this D, whichever I am trying to compute from this node to this node, is between 2 machines. Because there is a machine within me, which tries to send the data and find the difference. It tries to send the data and find the difference. How reliable the D is. So we need to optimize it to find what are all the noise that are being prevailing over there. Right? So there is a noise parameter measurement by which I am trying to do. I will show how this noise parameter measurement is being done. See this. So same thing I am doing, a simple mathematics. I am saying like, whenever the distance between one node and another node is going to be high, then automatically I am considering there will be more noise within it. I need to rely on that very much less. So that's why I am putting like, whenever the D is going to be high, then automatically I am dividing this NP, this is 0.02, and I am increasing this noise intelligence value with the computed D value. Once I computed this D value, which is nothing but this noise parameter Nij, for each distance I am computing a noise parameter and I am adding the noise parameter with the true parameter and I am going to take my Dij cap. So hereafter I am not going to rely on Dij, I am going to rely on Dij cap. Is it clear? So what I am trying to do, my system says, the data transfer between myself and the node over there says the distance between you and this difference node is D, but I am not relying on it. Based upon the D value, I am putting a constant parameter 0.02 as my error rate, and I am saying if the distance meant is 10 meter, then the noise parameter value is X. If the distance value is going to be 20 meter, then the noise parameter would be K, which is greater than X. Likewise, I am finding this X and K, which is the noise parameter, and I am adding that noise parameter with the truly computed distance. And I am saying that is my true DH. That's what I am saying.
The distance alone will influence this noise.
Yes, exactly. That's what logically, that's what I said. While I am trying to speak with you here, you will be purely audible, you will be fully audible. When I am going back and back and back, whatever I am trying to say, it won't be that much audible. So I am considering there is a noise prevailing in our infra.
Is there any other parameters?
There are several parameters. In electronics and instrumentation, in every node, there is 3 noise parameters that are considered. One is thermal noise. So that is what is the heat emitted by the devices that are being there. Thermal noise. Another one is inference parameters. That means there may be many, that means that wherever whichever we are speaking, it's not a homogeneous environment, it's a heterogeneous environment. So that is known to be as attenuation exponent factor. And the third one is what is we will be calling that as inference noise ratio. So what is inference noise ratio means any other explicit parameters we will be calling that as inference noise parameter. Right? So now I am computing my DAJ cap. So now using these three DAJs, right? Now see this algorithm. Using these three DAJs, A, B, C, D. I am considering like 4 anchor nodes, but logically we need 3 only. I am trying to put one point which is going to be the centroid of these 3 algorithms. So this is what about all continuous theorem says. So if I want to say a tetrahedral centroid meet at the rate of 3:4 rate, then the radius in which I am trying to find a particular location is 3/4 of L. So what I am trying to do is, with these 3 D values, I am trying to find a single x comma y, and I am not getting relied on that particular x comma y. I am saying like, in this particular rate only somewhere the exact location is there. Deploy some particles here and around me and try to put it as an optimization setup and try to find what is this exact point of this. This is what is the final found location parameter. Right? So that is what is being computed over here. That is what is being computed over here. Accurate locations are attained by considering each dimension. What is the dimension? This is D11, this is D12, this is D13. All the D11 cap, D12 cap, D13 cap has been identified. Then I am finding a TSO based setup. So many of you would be knowing about particle sum. So I don't want to go more about the basics. So I am using such an optimization algorithm and I am trying to find the revised determination. Right? So this would be my true accurate location. Now I found what is my true accurate location of this moving node without knowing the velocity and without knowing the path. But what I am doing, I am not finding the location every time. I am not finding the location like this every time. I mean, I am not finding the location every time. I am only finding the location whenever there is a requirement. What is the requirement? I am setting like, if the temperature is above 60 degrees Celsius, find my location, else you do the task. No need to find. Because this is an IoT setup. Right? So, now coming to my cost function. So this is my cost function which I am trying to optimize. So we everyone know about optimization. So EA is my estimated distance, set is my actual distance, EA is my estimated distance, set is what nearly my optimization distance. With respect to all the anchor nodes, I am trying to fine tune it and I am getting my optimized cost function. I am trying to get my optimized cost function. So whenever there is an increase in the cost function, I am deploying several particles in and around and I am trying to find the distance between this, distance between this, distance between this. Likewise, I try to find the distance between all and whichever gives me the exact or less error rate, I am fixing that particular x of t as my resultant distance. So now what I am doing, see the hierarchy. First, normal trilateration. In that I am finding the distance. Then I am refining my distance by incorporating the noise. Then I am finding the revised x command, x of. That's over. Yeah? Right? Zero. So now I found how to find the exact location by using this. So these are all the parameters which I have taken. So when we are discussing about my research paper, we will see about this shortly. Because we need to discuss this research paper alone. Now think in real-time environment. So what we are trying to do over here is like, we are trying to use this for a machine learning based system. That means what? Is like, whatever I am trying to do is, every time I am trying to find the D, and I am computing the noise. Instead of doing it, what I am saying is, if I am going to develop a solution of a location intelligence based IoT, let us say for an agricultural setup or somewhere over there, I know like this system is going to be set up on an agricultural land. This system is going to be set up on a hill. This system is going to be set up on a terrain which is going to be like a desert. put a system over there, do some pre-qualification phase, and make some random movements and find all the distances and find what is the error rate that is prevailing over there in the environment and model that as an NIJ earlier example. So that is what is this rule inference is in phase to say. During my training phase, I will be collecting different RSS values, different D values, and I will try to model if I am going to set up this particular network on a mountain, this is going to be my noise. So whatever D you are going to get, add with this noise. If you are going to set up this normally in a closed room, this is going to be the noise. So something like a training I am doing in prior to our implementation. So prior to our implementation, I am estimating all and I am trying to find what is the fuzzy rule. So I have shown some of the fuzzy rule bases also here. Right? Fine. So see this. So this is the fuzzy rule. So the node is in motion. After some certain distance, I will be trying to find this is the particular distance and its respective noise. This is the respective distance and its respective noise. Likewise, I will be trying to find the noise parameters in prior. That's how our machine learning algorithm works. Right? So how I have done this is, see this, I am putting this particular thing in a vehicle. Right? And I am trying to make this vehicle to roam around my entire campus, institute. So after every instance, it will try to give me some D, it will be trying to give me some respective x comma y. I am not going to rely on that same D and x comma y. I am trying to say, it gave like at this location, it is nearby 10 meters to my library. Then I will really go and check whether this is 10 meters or not. If it is not 10 meters, then there is some noise. Model it. Likewise, automatically, this particular vehicle which is trying to roam will identify a fuzzy based system to identify what is the noise that is prevailing over in the system. That is how ML works into the picture. So this machine learning model is to model the noise that is being done. Once I have modeled this system, while I am trying to do it in real time setup, see here, I am trying to collect over the nodes over here, right? I think so it's visible now. It says at particular time, this particular vehicle is near to IS department, this is near to CSE, this is near to IIM department. Likewise, now this CSE block, this IIM block and this IS department are nothing but my good, are on my reference points. Now I am trying to find what is the distance at this particular of 1758 of this time, what is the thing. Then for all these time units I am trying to model and I am trying to check. Now initially I have made my vehicle to move over the thing and I identify what is the distance and its respective noise also. Now in the testing phase, now I don't need to incorporate the D cap itself. Directly whatever D I am finding, I can directly give to the location testing phase. Right? So that's how this system works. So this is what we are getting it within my lab system. Right? See, the data has been collected on the field and this is the setup by which I am trying to do it and this is the setup by which I am trying to do it. Right? By using the setup I am collecting the testbed setup and we are getting the data into the on-field system. Clear? Right? So now I am trying to come for my results and discussion. So we need to compare it in terms of localization error rate. So this localization error rate is nothing but how I am trying to find the location parameters directly. So once I am trying to use the three optimization algorithms, I am trying to compare and see which is going to be a better one. Right? So now I am trying to compute with the same and I am trying to say which one is better in terms of the localization error. So what is meant by localization error? So it is nothing but 1 by n of root of our Euclid distance. What is the predicted distance and what is its constant distance? For all the n instances, I am going to generalize. That is what we are trying to call that as average node localization error. In several journals we will be calling that as ANLE parameter, average node localization error parameter. Right? So by this rate, I am trying to find what is the distance between each node to So now, two objectives are clear. One is I found the location without using GPS, without having the path information as well as the velocity information. I am able to find the first equation. First thing is over. The second important thing is I need to note about these parameters. I need to note about all the statistics in a closed setup where it is within the communication bridge. That is also done. The third important thing, how to establish this shortest path. Because I should not say like this is a smart system which can find the location, but at the same time I cannot say it requires 1 hour to find your location. It should find a shortest path based system. So that is what is our final phase of our work. So what we are trying to do over here is like, so yes, so we are trying to model with respect to the existing system and our proposed system, and we have tried to use it in two different networks. One is Digistra's approach, another one is A-star algorithm. So what we are ultimate aim is like, once that particular node location is being identified at the server, because in this place itself this pretty work cannot happen. Because the node whichever is moving to find the location is having a sensor node and identifying the distance. It doesn't have any computing facility. The Raspberry Pi or a computer is being required. So it will just collect the D1, D2, D3, all those values will be center stacks, and only in my remote server. So this is what I think so many would have been, this is nothing but an RPA, Raspberry Pi microprocessor, right? So yes, you can use. So directly you can use and you can set, and I am running my entire ML based setup in this RPA. Now the problem is how to communicate the estimated distance to the node, because I need to send to it, right? Now I collected the distances. Now I need to send to it back, you are in this particular location. That's why I am using the Digistra's approach. What is Digistra's approach? I am saying from this node, I will be having my routing table working on it. So this routing table says, if you are nearby this particular node, send to nearest reference node of it. If you are nearby this particular node, send to the nearest reference node of it. Automatically these reference nodes are static. So logically already its shortest path is known. So it will send the data of nearest to the location point and it will send the data. And as per our current setup, whatever we have tried to do, it requires 2.8 minutes to identify location of one node. As I can say, this is for a lab setup. If we want to commercialize the same, we need to make much more processing of the same. Right? So, what's next? What's the future, or what researchers are doing now, or what we in IIITDM Hybrid Intelligence Lab are doing is, up to now whatever we are trying to do is identify the D. After identifying the D, send it to Raspberry Pi board, and Raspberry Pi board tries to find the location and sends it back to the node. This is what is happening up to now. Why can't we use the same identification process and do the same computing aspect directly within the node itself? If I want to do the same, what is the powering source and what is the computation facility that is required in a particular moving node? That is where future technocrats are being working in this particular area. Right? So you can find the distance, but the latency or the delay in estimating the exact location is high. If you are trying to do the entire localization process or location identification process directly in the node itself, then it will be much more in a minimal time. You can try to find the location of a particular system, and that's where future is working. And even certain systems are clubbing this with respect to the cloud. That means what they are trying to do is they are trying to accumulate all the data and they are trying to put all the data to the system. Right? So I would like to, okay, directly concluded. I would like to finish my session at this point. So there are several future avenues, and you can see several research papers that are being working over there. So I want to show some of my research papers which are being related to this particular approach, right? Since there are several papers, I am just listing it out in terms of the papers. So these are some of the reference works which are coming out from my lab. So you can refer all these papers which are being. So these two are with respect to. So whatever up to now we are trying to do is with respect to data points. We are also working with some of the image-based setups and to do the same localization process. So instead of going to rely only on distance. So morning professor has discussed about some of the CV algorithms, right? So we are trying to power using some tiny ML algorithms, and we are having certain papers in that aspect also. So all my research aspects are specifically in this IoT and localization specifically. That's my pure area of interest. So if anybody are more interested, you can just go through these papers so that you will be getting more idea about it, and that's how my conference papers are all about. Again, all about this low cost identification, low cost system setup model. So this is how we all are working on, right? So this is what is our, if any research scholars or MTech interns are being interested to work on this area, we are having few openings in our lab, and it should be purely based upon this notifications for full-time PhD with the institute category. If anyone are really interested, you can apply for the same in that. It will be happening twice in a year. One in April and May, another one is November. Our November session got over. So if anyone are really interested to do PhD or something like an internship, you can apply for this paid internship in our lab. So it's funded by Government of India. Right? Any doubts? So if there are no other doubts, I thank the entire organizers to give me this opportunity. Thank you for listening to the lecture. And this is my homepage as well as my contact details. So if you want to move forward, or if you are having any doubts or anything related to this, you can always try to drop a mail, Preeth@IIITDM.ac.in. So we will be more happy to. So our ultimate idea is to inculcate this machine learning into IoT. We are not more working with the hardware aspects. We are more working with the software aspects, as we are from computer science domain with respect to specifically communication aspects. Any doubts? Right? Okay, then. Thank you.
So on behalf of Electronics and Instrumentation Engineering, I thank Mr. Dr. Preeth for his wonderful delivery of session and expertise on the IoT and valuable insights of the IoT in this session, and he finally gives some of the practical applications also. Sir, I request Sivarajan sir to honor our today's resource person. The file also.